Hello everyone, my name is Easwar and I'm a gRPC-Go maintainer. In this video, you'll learn about the basics of name resolution, how it fits in the gRPC client architecture, and also learn how to implement your own name resolvers. Name resolution or service discovery is a way for clients to discover network addresses of the services that they need to talk to. In gRPC, this works by mapping a human-friendly channel target string to a set of endpoint addresses. These addresses are then used to open connections to server instances. Apart from endpoint addresses, name resolution in gRPC also produces something called service config. This contains various settings that influence the gRPC channel's behavior when communicating with the server. These settings control things like retries, timeouts, the load balancing policy to use, among others. Before we get into name resolution, let's look at the channel target string briefly. Client applications specify a target string when they create a gRPC channel to talk to a gRPC service. This channel target is specified as a URI, as defined by RFC 3986. The channel target consists of a few important parts. The first one is the scheme. This determines the name resolver that gRPC will use to resolve the channel target. The second one is the authority. This is an optional component and could contain the name of an external server that gRPC could send requests to resolve the target. For example, in the DNS scheme, this represents the server to send DNS requests to. If the channel target does not contain an authority, the default name server, which is typically configured by the operating system, is used for name resolution. Last but not the least is the path. This is the actual name of the service that the client wants to talk to. gRPC provides a plugin system that supports the registration of name resolvers for URI schemes. This registration typically happens at application init time. The gRPC channel at runtime picks the appropriate name resolver from this registry based on the scheme used in the channel target. gRPC provides a bunch of name resolver implementations by default, and users can bring their own too. This enables users to implement their own logic for service discovery, thereby adapting gRPC to their needs. Name resolver implementations in gRPC consists of two key elements. The first one is the builder, or factory, or provider. This component registers itself with the name resolver registry at init time and is responsible for generating instances of the second key element called the resolver. The resolver takes as input the channel target string and produces as output a collection of endpoint addresses and service config. Name resolver implementations in gRPC return two key pieces of information to the channel. The first one is a list of resolved endpoints, each of which may have multiple addresses. Each address is typically an IP address and a port. The second piece of information is the service config, which contains various settings that influence the gRPC channel's behavior when communicating with the server. These settings control things like retries, timeouts, and load balancing policy to use, among others. Now that we've looked at the basics of name resolution, let's jump ahead and see how name resolution fits in the gRPC client architecture. As mentioned earlier, at init time, the different name resolver implementations register themselves with gRPC. This includes name resolver implementations provided by gRPC like DNS, Unix, XDS, etc. This also includes any resolver implementations provided by the user. Here, we see that the client application registers a name resolver for a scheme named custom. The client application creates a gRPC channel to the desired service and provides the channel target. Here, we see that the client application creates a channel to dns://example.com. To remind our viewers, a gRPC channel is a virtual connection from a client to a gRPC service. Underneath, it manages multiple actual connections to endpoints. Initially, the channel is idle and not doing much. The client application can either explicitly instruct the channel to connect, or it can initiate an RPC call. Both these actions trigger the channel to exit idle mode and start the name resolution process. The first thing the channel does is it looks up the name resolver registry with the scheme portion of the target, which is DNS here. The registry returns the builder for the specified scheme if one exists. If the scheme is not found in the registry, the channel ends up using a default name resolver. The return builder contains a build method for the channel to invoke. When the channel invokes the build method, a new instance of the DNS name resolver is created for the channel. This name resolver instance is specific to this channel. The gRPC channel then sends the target URI to the name resolver instance. The name resolver instance performs the actual resolution and returns endpoint addresses and the service config to the channel. Hope this gives you all a good understanding of how name resolution works in gRPC. In service mesh environments where endpoint addresses change frequently, DNS-based name resolution may be inadequate. Other mechanisms are often required. Here are a couple of examples. The first one is XDS. XDS provides a set of APIs designed to dynamically configure the behavior of data plane software. Originally developed for the Envoy proxy, XDS is expanding to become a more general-purpose configuration standard for various data plane components, including gRPC. gRPC offers a custom name resolver compatible with XDS APIs. For more information on XDS support in gRPC, please refer to a video by gRPC maintainer Mark Roth, linked in the description below. The next one is Consul. Consul is a widely used service networking tool that provides an API for service discovery. Open source implementations of name resolvers that work with Consul are available. If you want to build your own name resolver, there are two options at a high level. The first one is watch-based. Here, the name resolver implementation opens a connection to an external server and waits for updates to be pushed to it. The XDS resolver that ships with gRPC is an example of a watch-based resolver. The next is polling-based. Here, the name resolver implementation queries an external server periodically or when explicitly instructed by gRPC to receive updated address information. The DNS resolver that ships with gRPC is an example of a polling-based name resolver. You can also find more information in our user guide on name resolution, which also contains some links to language-specific examples. That's all for today. You can find more information about us on our website, our YouTube channel, our GitHub repo, and our mailing list. Feel free to reach out to us if you have any questions. Thank you again for watching. Bye.